Hi guys, my name is Lydia Lestari Lamatengo. In this video, I will explain inorganic chemistry practicum. Practicum title is Modification of Sulfur. Sulfur is chemical element in the periodic table that has the symbol S and atomic number 16. Its form is a tasteless or odorless multiple nonmetal. Sulfur in its natural forms is a yellow crystalline solid. In nature, sulfur can be found as an essential element for life and is found into amino acids. Its commercial use is mainly in fertilizers, but also in gunpowder, matches, and insecticides and fungicides. Solid sulfur has allotropic forms, namely rhombic and monoclinic sulfur. The sulfur that we usually see yellow is rhombic sulfur. Rhombic sulfur below a temperature of 19.5 Celsius, above 19.5 Celsius. Rhombic sulfur turns into monoclinic sulfur, which then melts at a temperature of 113 Celsius. Sulfur is readily available in nature as an element, as H2S and SO2 in sulfide air metals and as sulfates and SO note. Sulfur has a strong catalyst and form compound without analog with UOCP. Element sulfur has the cathode materials is natural, abundant, environmentally friendly, and cost effective. Next, tools and materials. Tools we use in category 1 like this picture. Next, tools we use in category 2 like this picture. Next, materials. Specific materials is CH3COH, H2SO4, K2CrO4, sulfur, and general materials is tap water, aqueous, copper chips, tissue, washing soap, sucrose, ethanol, distilled water, and filter paper. Next, experimental works kind. Experimental works kind. Firstly, modification of sulfur. Method 1, firstly start. Next, blended 0.5 gram of sulfur in evaporation cup by heating the sulfur until it melts and freezer. Next, observe crystal strips and crystallites. Finish. And then method 2, firstly start. Next, heated 0.5 gram of sulfur powder in the test tube while shaking the tube. Observe the sulfur color change. Next, the sulfur becomes liquid and finish. Next, experimental works kind is characteristic of sulfur acid. Firstly, start. Next, heat a patch of copper in the test tube containing 1 ml H2SO4, not boiling. Next, observe the activity in the test tube and write the reaction equation. And next, water of vapor formed in walls tubes. Next, place in the vapor moistened with K2CrO4 solution in the mouth of the test tube in step 1. And then observe the color change in the filter paper with the reaction equation. Next, there are yellow spots on filter paper and finish. Next, method 1, firstly start. Next, put sucrose into the test tube and a few drops of concrete H2SO4. Observe and take a note the activity in the test tube. Next, sucrose and dissolve in H2SO4 and finish. Method 2, put 2 ml of acid into the test tube, add 2 ml of ethanol and 2 ml of concrete H2SO4 and heat the test tube using a Bunsen burner. Next, observe it and take a note the activity in the test tube and weighted direction equation. Unfinished. Next, observation result. Treatment 1. Modification of sulfur. Blended 0.05 gram of sulfur in evaporation cup by heating the sulfur in until it melts and let it freeze. Observation: when the sulfur melts, the sulfur is red, and after freezing, sulfur forms yellow crystal. And heated 0.5 grams of sulfur powder in the tube. Observation: sulfur turns in the color forms yellow to brown. 2. Characteristic of sulfur acid. And 1. Treatment: heated a patch of copper in the test tube containing 1 ml H2SO4, not boiling. Observation: bubbles appear in the tube. Place and the filter paper moistened with K2CR4 solution in the mouth of the test tube. Test tube in steps 1. Observation: filter paper that was originally yellow turned white. Next, put sucrose into the test tube and a few drops of concrete H2SO4. Observation: the solution discolored to black. Next, put 2 ml of acid into the tube, 2 ml of ethanol and 2 ml of concrete H2SO4. Heated the test tube using a Bunsen burner. Observation: it forms bubbles, smells like wind, balloons, and the ringlets don't change color. Next, discussion: modification of sulfur. First modification: sulfur exits in crystalline form depending on temperature. In this experiment, sulfur melts because of the nature of the natures itself. It will melt if it is above the heating temperature of 95.6 Celsius. After freezing, prismatic needles are formed, namely monoclinic sulfur, or also called beta sulfur. The beta sulfur molecular needles consist an S8 ring, which is an octahedral crystal. The second modification, the sulfur powder becomes a brown-yellow liquid because the string is broken. If the temperature continues to be raised, the liquid will become viscous and the color will turn darker because the string is breaks and forms a change. Next, a characteristic of sulfur acid. The first step is to heat a patch of copper with 1 ml of concrete H2SO4. When heated, the solution boils, forms the result of observation. Gas bubbles formed. Copper is soluble in acid but can dissolve in sulfuric acid to form copper sulfate and sulfur oxide. Cu plus 2H2SO4 produce CuSO4 plus SO2 plus 2H2O. Sulfuric acid reacts with copper liquids hot, concreted sulfur acid, and this reaction produces sulfur dioxide. And this happens because hot concrete sulfuric acid acts as an oxidizing agent. In the reaction that occurs in the above equation produce sulfur dioxide gas forms the reaction between copper and concreted sulfur acid characterized by the presence of gas bubbles. The second observation was the that the gas bubbles produced were tested by placing filter paper most stained with K2Cr2O7 above the mouth of the test tube. After a while, the filter paper turns into a white brown color. This is caused by the presence of SO2 gas produced from the reaction copper and H2SO4. This SO2 gas then reacts with K2Cr2O7, which is marked by a green color on the filter paper if it is done for a while. However, the result we obtained with his brown filter paper. The reaction that occurs is Cr2O7 plus SO2 plus H plus and produce to Cr3 plus SO4 to mean plus 5H2O. The third observation, the nature of sulfuric acid as dehydrating agent is reacting sucrose with concreted H2SO4. From this experiment, sucrose is black. The equation for the reaction that occurs C12H22O11 plus H2SO4 produce 12C plus 11 H2O plus H2SO4. It can be seen that H2SO4 decomposes sucrose or separates hydrogen and oxygen from the sugar. Concreted sulfuric acid is a strong dehydrating agent. Dehydrating is the release of water molecules from the material that is attracted by a material such as H2SO4. The presence of carbon produced from this reaction can be seen by the formation of a black color in the mixture when added with concreted H2SO4. The fourth observation, the nature of sulfuric acid as a catalyst in the formation of esters is reacting to a milliliter of acid 2 ml of alcohol and 2 ml of concreted H2SO4 deheated. Before heating, the tube wall feels hot. This is due to the reaction between sulfuric acid and acid alcohol. Then it is heated, the produced air bubbles. The reaction can be written into the equation CH3COH plus C2H5OH plus H2SO4 produce CH3COOH2H5 plus 2H2O. From the above equation, it can be seen that the reaction is an esterification reaction, whereas carbolic acid is reacted with alcohol with an acid catalyst to produce an ester and a water molecule. Here it can also be seen that H2SO4 acts as a catalyst in the esterification process, and the experimental results obtained are that it smells like candy, which indicates that the reaction is an ester. Next, conclusion. Sulfur can be modified, which is escalate and allotrope. The result of the modification aromatic S8, the crystal from obtained is affected by temperature. While sulfuric acid has properties as an oxidizing agent, dehydrating agent, drying agent, as a catalyst in the formation of esters. Thank you for watching.